Hi guys, today I'm going to be working through questions 1 to 4 from 3.4 applications of quadratic equations. So this is from your Year 11 Jacplus textbook, and we'll start with question 1. Notice that these are all technology active, so you can use your CAS in order to work them out. So this first one is really similar to the worked example, which I went through in a previous video. It talks about someone selling fish or salmon at the market, and the first thing we're told is that the owner of the fish shop bought X kilograms of salmon for $400. So if we wanted to work out the number of kilograms, we would say 400 divided by the cost of each kilo. Or if we wanted to work out the cost per kilo, we'd say $400 divided by the number of kilograms. So if you had 10 kilos of salmon and you paid $400, you'd say, well, $400 divided by 10 would be the cost for 1 kilo. So with that in mind, I would say, well, 400 over X is going to be the cost of the salmon per kilo. So that's one piece of information we have. That's what that first bit is telling us. At the end of the day, all except 2 kilograms of the fish were sold at a price per kilo. All except 2 kilograms of the fish. So remember, we're saying that we've got X kilograms. So the amount sold is going to be X minus 2. And the price that they're sold for is $10 more than what the owner paid at the market. Okay, so the price sold that he's going to sell them for is going to be the amount that he buys it for. So this is the cost per kilo, 400 over X. And then we're adding $10 onto that. So 400 divided by X, that'll give us the cost for 1 kilo that he pays for it. And then, well, now he's going to sell it for $10 more than that. So there's our next bit of information. So next, from the sale of the fish, a total of $540 was made. So we can say revenue is $540. And if we think about, what that means, well, the revenue is going to be the price he sells it for, and times the number of kilos that are sold. And we already know all these things. The amount sold is here. So we know that that's going to be in our equation. The second thing, the price he sells it for, well, we've already worked that out too. Here it is. So we can make an equation now which we will be able to solve. So we've got 400 on X plus 10 times X minus 2, and that's going to equal 540. So at this stage, you can use your CAS to solve this. I'm going to expand it by hand and cross multiply so that we have a bit more practice with that. But by all means, you could solve using your CAS here. So here we use FOIL to expand the brackets. 400 over X times X is just 400. 400 over X times neg 2 is negative 800 over X. 10 times X is 10X. And 10 times neg 2 is negative 20. So that's going to equal 540. So if we, simplify that down, we're going to get 10x squared minus 160x minus 800. And well, that's going to equal 0. So remember, when we're going to factorize and solve, we need to use the null factor law. And the null factor law means we have to equate to 0. So now that we've got that, again, it is a CAS question, so you don't have to go to this stage, but I'm going to divide by 10. So I've just divided both sides by 10. And this is my equation now. And now I'm going to cross factorize this. So negative 80, I've got to get to negative 16. So let's think 20 and 4. 20 minus 4 gives us 16. Negative 20 plus 4 would give us neg 16. So 4 times x is 4x, and x times negative 20 is negative 20x. And that indeed does equal negative 16x. So we can say we've got x minus 20 and x plus 4 in our brackets, and that equates to 0. So notice that now we can solve each one. We can say x minus 20 can equal 0, and we can also say x plus 4 can equal 0. So let's add 20 on both sides. We get x equals 20, and that's a sensible answer. The other one, though, we're going to get x equals negative 4, and that's not a sensible answer, so we'll reject that. So we can answer that by saying, let's just double check exactly what they're asking. How many kilograms of salmon did the fish shop owner buy at the market? So 20 kilograms of salmon. So this one is correct, 20 kilograms of salmon. Make sure that you actually write that. Don't just leave x equals 20, because that's a silly answer. If someone asks you how many kilograms of fish do you have, you wouldn't say x equals 20, you'd say 20 kilograms. So we want to make sure we've got the units there and that we answer it, we actually answer the question. So let's move on to the next one. So number 2, application question number 2, and this is another one which is quite similar to the worked examples here. So the surface area of a sphere, so I'm going to call that A, is directly proportional to the square of its radius. So the square of its radius, that means r squared. So I'm going to call, yeah, I've already said I'll call it A. So the surface area is going to be k, directly proportional to the square of its radius. So this is my formula here, and just like the example, they're now giving us some information to sub in so that we can solve for k. So if we don't have that, just pretend that wasn't there. If we had to calculate the radius, well, we would have 360 pi equals k r squared. There's too many variables. We can't calculate the radius without having the k as a variable there. So we do want this part here. And this is going to mean we can solve for k. So when the radius is 5 centimetres, the area is 100 pi. So that gives us 25k equals 100 pi. And then, of course, we'll just divide by 25. K is going to equal 4 pi. So now that we've got this k value, we can rewrite the formula as A equals 4 pi r squared. So now we can just find out the value of r by subbing in this value, 360 pi, for the area or surface area. Equals 4 pi r squared. Let's divide everything by 4 pi because I'm looking for r, and I'm going to get the pi's will cancel, and 360 divided by 4 is 90, equals r squared. And these would cancel, and that becomes 90. So r squared equals 90, and then, well, now we just take the square root of both sides. And of course, if we're talking about square rooting something, of course we would have plus or minus. But because this is talking about a radius, we're only going to deal with the positive. So it's root 90, but we can simplify this. So let's call this 9 times 10. Well, that will simplify to 3 root 10. So our radius is 3 root 10 centimetres, and I'll just double check that we are looking at centimetres. Yes, we are. So notice here that I'm not making a decimal. The question does not ask me to use a decimal, so I don't use decimals. I don't round it. I don't do anything. I leave it as exact values. And in methods, we usually use exact values. Let's go to the third one. Another proportional one, the cost of hiring a chainsaw, so I'm going to call this C as the cost, is going to be $10 plus an amount that is directly proportional to the square of the number of hours for which the chainsaw is hired. Okay, so there's my formula. If it costs $32.50 to hire the chainsaw for 3 hours, okay, so there's our information so we can solve for k. So I'm going to sub that in now. So the cost is $32.50. 10 plus kh is 3 squared. So we get 9k plus 10 equals 3250. And look, I'm going to change this. I'm going to change it to a decimal in a minute. 9k, oh not a decimal, sorry, a fraction is going to be 2250. And well, 22.5, well, we can write that as 45 over 2. And of course, well, 45 over 2, we're dividing by 9 now. So we get k equals 45 on 18. And if we divide by 9 on both sides, well, we're going to get 5 on 2. So our k value is 5 on 2. And the reason I've changed it into a fraction is because it's just much easier to work with. So it was quite nice to subtract the 10 on both sides without using a fraction, just use the decimals. That was easy enough. But then when we're dividing, and well, now that we're going to be using k, I think it's going to be much easier that we have k as 5 over 2 rather than 2.5. So let's have a look. So let's write the formula again. C equals 10 plus 5 on 2h squared. So this is our formula now that we know k. And we have to find to the nearest half hour the length of time for which the chainsaw was hired if the cost was $60. Now I think a lot of people will leave this blank, this part, because they will be put off by this to the nearest half hour. So let's just cross that out for the meantime and sub the 60 into the cost. Because even if you didn't quite understand what it meant by the nearest half hour, well, if you started off, you might realize what they mean. But secondly, even if you didn't realize and you did most of it, you'd get most of the marks there. So let's minus 10 on both sides. So we get 5 on 2 h squared equals 50. And now I'm going to be dividing by 5 on 2. So keep, change, flip. I have divided by 5 over 2 by keeping the 50 over 1, and changing the division to a multiplication sign, and flipping this fraction here to 2/5. So h squared is going to be 50 times 2 is 100 over 5. 100 divided by 5 is 20. Square root both sides, and let's see, we get h equals plus or minus root 20. And of course, again, we're looking at the number of hours, so you're not going to have a negative number of hours. So we can reject the negative and write root 20. And of course, we should simplify this third to 2 root 5. So h equals 2 root 5 hours. And this is 100% correct. And they didn't, and if they didn't ask us to put to the nearest half hour, that would be our final answer. But they do. They ask us to the nearest half hour. So this is where you can put into CAS. So to the nearest half hour. And what you'll get when you put it into CAS is that h equals 4.4721 hours. And people don't really know what to do with this. They think, well, this is 47 minutes. So, okay, it must be 4 hours and 47 minutes. No, it's not 4 hours and 47 minutes, and therefore the nearest half hour would not be 5 hours. And this is the part, I think, where most people will go wrong. So what we need to think is, well, if this said 4.5 hours, you'd know that that's not 4 hours and 50 minutes. You'd know that 0.5 hours is 30 minutes. So you would say, well, 4.5 hours is 4 hours and 4.5 hours. So that would be easy. When it looks like this, 4.4721, people don't really know what to do. Well, we know we can say 4 hours, and this is a part of an hour. So all we need to do is do 0.4721 times 60, and that will give us the number of minutes. So let's go ahead and do that. 4 hours, and CAS tells me it is 28.32. So this is very different to if you had thought it was 47 minutes. It's approximately 28.5 minutes. So our final answer there would be 4.5 hours because it's to the nearest half hour. So 4.5 hours you can hire for. So if you're unsure of that, think about the example I gave if it was 4.5. You know that 4 hours is 4 hours and 30 minutes. So how you can think of that, 4.5, if we say it's 4 hours and 0.5 times 60 minutes. And you can see 0.5 times 60 is 30, so that would be 30 minutes. So the point is this one wasn't 0.5, but the 4.5 really can help you to see how others work. I think that's probably the hardest part of this question. Let's move forward. So these look like they are all proportion ones. So let's go for 4A. The area of an equilateral triangle varies directly as the square of its side length. Okay, so let's see. The area, so I'll say that's area of a equilateral triangle, varies directly as the square of its side length. Okay, so KL squared. So this is pretty much the same as what we've done previously, not too hard. A triangle of side length 2√3, so that means L is 2√3, has an area of 3√3. Okay, so let's sub that in first because we're going to find K. So 3√3 equals K times 2√3 squared. And now, well, this is not too hard. 3√3 equals, but people don't really remember that you have to square both things. So 2 squared is 4. Oops, better put the K in. And then √3 squared, that's √3 times √3. So that equals √9, which equals 3. So there we go. So now we have 3√3 equals 12K. Let's divide by 12 on both sides. And we get K equals 3√3 on 12. And of course we can divide the top and bottom by 3, which means this 3 will go. And 12 divided by 3 is 4. So our value for K is √3 over 4. And if you had got 4 over √3, for example, you'd want to rationalise the denominator. We don't, so we don't need to rationalise the denominator, but just in case. So let's now use that information, and we've got A equals, what was it, KL squared, so √3 on 4 L squared. And let's see, we've got, calculate the side length if the area is 12√3. 12√3 equals √3 on 4 L squared. So now I'm going to be dividing by √3 over 4 on both sides. So we've got 12√3 over 1 divided by √3 on 4, so keep, change, flip. And notice how I put this 12√3 as a fraction over 1, because then I can use the fraction multiple or division of fraction rules really effectively there. So, and then I get L squared there. So this can cancel, this can cancel. 12 times 4 is 48. 48 divided by 1 is 48. So L squared is 48. And again, we're looking at a physical length, so it's not going to be negative. So that means, well, I'm going to simplify this. So what will we get there? We'll get 4√3 equals L, and well, yes, that would be it. There's our answer there, and it is in centimeters, I believe. Yes. Now they're not asking us for decimals, so don't do decimals. I'm just going to write that again. Length equals 4√3 centimeters. Okay, so that's the first one. I haven't really left enough room there. I'm just going to cut this out and bring it down. And we'll do the second one. So 4B, let's see what they want us to do here. The distance a particle falls from rest is in direct proportion to the square of the time it falls. Okay, the distance a particle falls. So I'm going to say, let that be D, and direct proportion, that's our K value. So D is going to be directly proportional to the square of the time it falls. So that's our formula there. Okay, so usually they give us some values, so we work out k, and then we can solve for time or distance there, but they don't do that this time. They're saying what is the effect on the distance fallen if the time of the fall is doubled. Okay, so there's no solving for k, we're doubling the time of the fall. So double something, you times it by 2. So we're going to get d equals k 2t squared. And now, here people are going to get unstuck because they're going to not have brackets and they're not going to square the 2. So all that is squared. So we get d equals k 4t squared. So I've squared 2 and I've squared t. And now, that means d equals 4kt squared. And this now shows us an answer. We've got this and we've got this. So when we doubled the time of the fall, what happened? Our whole thing was times by 4. So it must mean that the distance fallen will be times by 4. All right. Let's do the last one. The number of calories of heat produced in a wire in a given time varies as the square of the voltage. Okay, so the number of calories of heat produced is given by, it varies, in a given time varies as the square of the voltage. Okay, so this is kV squared, and V is our voltage. If the voltage is reduced by 20%, okay, so this is a little bit tricky. What is the effect of the number of calories of heat produced? Okay, so if we are going to reduce it by 20%, reduce by 20%, then what's left? 80% is left. So that means we've got C equals K. Our new voltage there is going to be 80% of the voltage, or 0.8 of the voltage, and squared. So now we should be able to, square this. Don't forget you're squaring the 0.8 as well. 0.8 squared is 0.64. And then, that's going to be C equals 0.64 kV squared. So here is our equation once we have reduced the voltage by 20%. So now we just need to interpret that. So, and it's this 0.64 here that's like we're interested in. So they're asking us, what is the effect on the number of calories of heat produced? So the number of calories of heat produced will be 64% of the original. So there it is. And that completes question 4. So we've got 1 to 4 now, and I will make a new video for the next set.